This is Darshan, and I warmly welcome you all to the C++ Bootcamp organized by Coacher. For today's session, our leads, Rohit, Nitin, and Sophian will be sharing their knowledge to help you strengthen your C++ skills and prepare for Decode DSC. Decode DSC is a flagship event scheduled for 3rd and 4th September, where Mr. Abdul Bari, one of the finest educators in the field, will guide us through key DSA concepts. Registrations are closed due to overwhelming response, which truly reflects the quality of this event. Without further delay, I invite Rohit to kick off this session.
Hello guys. Today I'll be carrying on the session. First we'll start with C++. So what's C++? So C++ is a programming language, and there are other programming languages as well, like Python, Java, and C++, and other stuff, JavaScript and stuff. But for DSA, C++ is important. You can use with other languages. You can go with Java, you can go with Python, but no issues. You can C++ is a better choice. So, without any further ado, we will go straight to it. So, can you all see the screen?
Yes, yes.
Okay.
It's visible.
Yeah. So this is your VS Code. Okay. So VS Code is an editor where you can code all your programs. Initially, they ask you to open a file, so you can open a folder. You'll get an option to open a folder. You can save it as C++ bootcamp, no issues. Okay. Now to create a file, since we are working with the C++ file, we should end with a .cpp. So we can give any file name, no issues. So main.cpp. Right? So this is your coding area. The blank space you can see is a coding area. So initially, the boilerplate code is like this. It is hash include with, as well as you guys can also join along. You guys can write in a VS Code or online compiler. Anything is fine, no problem. Okay. About the template, Nitin will come to it later on. We'll focus main on the code. Okay. Yeah. So this is your boilerplate code, and this is the initial setup. Mostly you'll be using only this much for the initial setup, and this is where you inside this part over here you write your code. Okay, this is where you type your code. Okay, so now let's start with basic stuff. Let's start with a simple topic called variable declaration. So in C++, you can declare a variable with different data types. Example, you know, okay. So for example, let's say that you want to store a name. So what's a name? Name is actually a string. Why? Because names do not have any numbers. So basically you can divide your data types in three different parts. One is a name, or words, or a number, or a decimal. We'll look into one by one. So in case of name or any words in that case, we use a data type called string. Okay, so that goes like this. Okay, string, that's the thing. In case of numbers, we go for int. And in case of decimal, we go for float. These are the three stuff. This all you'll need to know for DSA. Okay. But how do we use this? Let's look into that. So to create a variable, first you'll need to mention a data type, because when you're making a variable, you'll need to tell what type of data is going into that variable. So let's name initial as string, and let's keep our name, or let's keep the course, for example. So course. Now after you create this is enough. You can leave it as it is, or if you know by default a value for it, you can keep equal double quotes. Note that there's a double quote at start and double quote at end. In middle of the double quotes, you need to type the course name. So let's take DSA, which is data structures and algorithms. Okay, that's all. That's all is variable declaration. So it's your data type, then the variable name you want to give, and the value. Okay. So now you created a variable. You kept the content inside, but how do we see this variable? Like, how do I run a code and see the variable? For that, you'll need to use this thing of count. It's C out, but count. Okay. And you can just mention the course. Okay. So what does it do is, after you print this, it will print course. Where will it print? I'll be showing you now. So before going anything further, if you can notice there's a dot over here, which means it's unsaved. So you'll need to always save your code before you run. So what you do is press Ctrl S, or you can go to your file and save here. Okay. If it's no longer dot, it means it's saved. Okay. Generally, for you to run a code, you have to open the terminal, which you can go by terminal and new terminal. Okay. Here, I hope all of you installed a G++. In case of online compilers, you will have a plus icon here. You can just click it and go ahead. No problem. No problem. But in case of VS Code users, type G++, then the file name. Okay. main.cpp. And this G++ is a compiler that changes your code into an application which you can run. So you have to give it a name for that application. So let's give again the same name, main.exe. So exe stands for the application name. Once you do this, it will compile and you can see a file coming here. Now you can't run this file directly because if you click on this, you get this error, which is not needed. We have to run from the terminal. Okay, hold on. Yeah. Okay. So to run this dot, and then this is the inverted slash. Okay, it will be above your enter. So be careful on that. Main.exe. If you do this, you'll get what we printed here. Great. Okay. So you did your official one. If you want to do something more easier, you can remove all this. You can directly then see out hello world. Again, Ctrl S. Okay. Okay, yeah. You have to keep a semicolon. Don't forget that. Semicolon is a must. And again, you can do the same thing. G++ main.cpp. You have to keep compiling every time when you save the code. You get it? So you have to compile. Then you have to again run it. Only then it'll change. If you don't compile and if you try to run again, there won't be any use. It won't work. Okay, so you can see this is being slow, like it's going to slow you down if you keep compiling every time and running. So the alternate option is to use this function called this plus. To get that, click this extensions. It'll look like 4 box and 1 box coming up. Okay, in that search for code runner. Okay. And click the first one, the Jan Han. Click that one. Okay, and install it. So yeah, you'll get like this option, install it. It will install for you. Okay, you don't have to download anything, you can just directly install. And once you're done this, you can return back to your folder. Now, to run this, usually over here you'll get this play button with some small gear nearby. So don't do that. You can click this drop down and click run code. Okay. With this, you'll get your output over here. You'll get your output right from here. Okay. So if you do this thing multiple times, at one point you will get the plus over here itself, which is useful. Okay, so there are two ways. One is to compile, then run the code, or other ways to click this button directly. All of you guys will be using this, so you can go ahead with that. Okay. Now let's come back to the data structure. Okay. So we saw words, we saw how to handle words. But what about numbers? Simple. So as I told you, for numbers, it is int. Int stands for integer, so it can be +1 or okay, wait, 1%. Showing no input file when I try to compile. Oh. Did you open it from the folder? Like, okay, wait, I'll just do one thing. Okay, so if people are getting some error, first you'll get like this. If you click this explore over here, you'll get this open folder. Click open folder. Inside it, go to your respective directory. Okay. Oh wait, can you guys see it? Nitin, can you see a file explorer open?
Yes, yes.
Okay. Okay, so now you can go to wherever you want to. So I'm going here. Okay, you can choose any folder. After you choose a folder, now try running a file from this folder. You should get it. Okay, just try it out again. Okay. Yeah. So we'll carry on. Okay, so yeah, we are talking about numbers. So int stands for integer. So the number doesn't have to be only necessarily plus values. It can even be negative values. Okay, so let's take a simple case. So let's take a score, for example. Okay, so in score, again you can give 90. Okay, in score equal to 90, meaning it means that there's going to be a variable of the data type integer which will store a value 90. Okay. Again, to view this, you can just do cout score and semicolon. Everywhere semicolon. The only place where you won't be using semicolon is for include and this part. This part you won't be using, but other places you will be using. Okay, again save this and click the play button here. When you do like this, you get 90 directly. Okay. But now let's just say that first it has to be 90, then we want to change it to 70. Maybe first they awarded you 90 marks, then you realize that no, that's an error, ma'am corrected wrong. I should get 95. You can do that. Now, again, if we go with the same type, int score equal 95, that'll be a problem because at this point, you're again declaring the variable once again, which is not correct. Usually, you should declare a variable only once. you should not declare twice. Okay, so first you declare it score equal 91. That's enough. You don't have to declare it again. Now all you're doing is you're manipulating the data. Declaring is different, manipulating is different. So here you're just manipulating the data. Okay. Like how in your exam paper they'll give the full mark and just nearby they'll just add +5. They're not like making an entire new mark, right? They're just adding some more. So you have to do just score equals 95. Now what you're telling us, you're telling that this variable equals 95. Right. So suppose type in the terminal again for random. Oh, okay. So yeah, nothing. It's simple, right? So okay, we'll run this one. After this, we'll go to yours. Okay. So yeah. So initially the score is 90 and now it's 95. But how do we see the change? Again, just you print it out using cout score. Okay. Yeah, and then for Kishore, this is how you do. So again, make sure that you guys are storing all the code in a particular folder called any folder, and you're opening terminal from there. Okay, don't directly do it. May try to find the code from some other place and it won't give you. Okay, so do this G plus plus. Okay, then your file name. That's CPP. Then give any name. So you can give main.exe. Okay. Yeah, it's compiled. All you have to see this whole thing once again. You can run next line. This is dot slash main.exe. Got it? Kishore? You can unmute if you have some doubts. No problem. Okay. Okay. So yeah. So we told it 90 and it printed 90 first. Then we printed 95. It printed 95, but what's odd? The thing is that it's printing next to each other. Is it readable if you do like this? It's not. Okay. So what do we do is we have to keep some sort of a space or a new line between these two. Okay. So what we can do is after you print the first time score, there should be a space before you print the next score. So what you can do is cout score space, do again the same thing and keep a quotes and keep space. Okay, so now we are putting a string here, and that's fine. It's fine to keep a string and a number here. It's okay. You can print the number, then you can print the string, then you can again print the number. No issues. Okay. And how many people are having error in the score run? If many are having error, then we can close, I guess. Okay. Wait.
Okay.
I hope you guys can run. Okay, you can listen. I'll just use C lines. Yeah, I can use C lines. C line will work. Not able to generate main.exe. Like you're not able to see this file the main.exe. Ritik, did you install G++? Like we sent a video on how to install G++. Oh, good file even. Oh, wait. Okay, see, if you guys having problem with the local, doing this in local, you guys can move to online. You guys can use program is C++ compiler. They help, it works, okay? There's no issue. Maybe after the class we can work on it and I can help you troubleshoot it. Okay. Yeah, you can follow what Nitin says. Okay. Okay. So you have to follow the same file name that you're following that. So if you created some other file name here, you have to use that file name over here. You should not use main.cpp if you main something else like world.cpp. You should not do like that. Okay. So yeah. So what we're doing here is we are printing the score initially, then we're printing a space in between, then we're updating the score and again printing the score again. This time what happens is the 90 score becomes 95. So again, if you run this, hold on. Yeah. So now what happens is you have 90 and you have a space and 95. What if I want to put it in different lines? First, I want to print 90 in one line and another line I want to print 95. Then you can do enter. Okay. Again, you can go with this one. Now you see 90 gets printed one line and 95 is in another line. Okay. So that's the thing. Okay. So those having problem with the local, you can move online and you can follow the steps. It'll be the same. Actually, you guys will find it easy. You can just press the play button. Okay. So this is for integer. So far what we saw is we saw for string. Your string you can keep name and you can keep Rohit. You can even print it out. You can directly keep my name is, and you can keep like this. And again, if you want to keep this, if you want to keep it in a new line, you have to end with L. You have to do enter. Okay. Save it. And once again, if you run, you get compiled. And then if you run it, you'll get your name and this thing. You can change your name everywhere. Every time. Okay. This is the thing. Now, what if I store this string value in a variable that's declared for a integer? Let's write it out. So let's do int grade. So grade was supposed to be some number, but we'll just keep like I got S grade. Okay. Now the problem here is you're declaring a different variable to a different data type to different variable. Example, it was supposed to receive an integer, but they're giving a character or a string. So you will get the red squiggly lines because you're giving error. Even then, if you don't get in the online compilers, when you're compiling, you will get an error. So here when you're compiling, you can see a error like invalid conversion. Invalid conversion means you're trying to convert this string into integer, which is not possible. Okay? So the alternative method is to name this as a string or to give it as a int. You can go with int. Int, and over here you can name it as 88. Works fine. Okay, cool. So that's your thing. So I told for words, I told a variable how to create variables if in case you're storing words. I told if you want to store numbers, you can use int. For about decimal values, example, a CGPA, you can store it like float CGPA 9.37. Simple. So it's your usual maths. How you keep 9 point something, you can keep that over here also. No change in that. Okay. Again, when you want to view, you can view all together. So let's view all things together. Let's view the score. Then let's put the space. Then let's view the CGP as well. Okay. So now if we compile, you get this. Again, as we see, there's no space in between this. Why? Because after the previous count, so here was your previous print. Here you didn't end with a new line. Every time when you want to print the new line, you have to keep endl. So keep an endl here. And now if you try this, it should be fine. Okay. So yeah, it's showing all things clearly. So showing your score, space, CGPA. Alright. Okay. So that's the thing. Now, let's move to some few maths related ones. Don't worry, it's not a calculus or your differential or any of those. It's your simple stuff. Okay. It's going to be a basic operator, addition, subtraction, multiplication, division. Okay. So let's start simple. Let's tell that we want to add two numbers. So first, let's declare a variable. Okay. And when you want to declare a variable, you can give us some numbers. So let's go 5. Let's declare another variable. Okay. You can give any variable. That's not a problem. And we can name this 6. Okay. Now let's first find the sum of these two. To find the sum of these two, really simple. A plus B. That's all. You just have to add A and B together. So you just have to do A plus B. And let's keep an indel so that we can go to the next line and print from the next line onwards. In case of subtraction, any guess? You guys can put it in the chat. A minus B. Okay. So this will subtract 5 from 6. Since 5 is a lower number than this. Yeah, madam. Correct. Good job. Okay. So now you'll get minus 1, which is fine. Okay. Now in case of a multiplication, generally in math we'll type A, X, B, which is not correct because here x is actually a x may be a variable. So you should not use x. Instead, you can see above the 8 in the keyword a star. That will be a multiplication. Okay, so that's your thing. Okay. Then if you want division again there are two things. So if you want to divide, let's say that you want to divide a by b, a by b. So this will give you the uh give you the result of the division. It won't give the remainder, it give the dividend. Okay. Yeah. In case you want a reminder, you have to do C out A modulus B. Modulus is for remainder. Okay. So now that we did all the possible combinations, let's run this code and check it out. Okay. Compare. And you got it. So 5 plus 6 is 11. 5 minus 6 is minus 1. 5 into 6 is 30. 5 by 6. 5 by 6. What's 5 by 6? If you try to divide 5 by 6, what will you get as your quotient? There won't be any quotient because 5 by 6 is 5 is the numerator is less than the denominator. So there's no quotient. Quotient will be 0. But you will get the remainder of 5. That's why when you're dividing a by b, you're getting 0, but you're getting a remainder of 5. Okay. Let's take for a better example. Let's take 12. Okay. So again, let's compare. And let's run. So 12 plus 6, 18. 12 minus 6 is 6. 12 into 6 is 72. And 12 divided by 6 is 2. And there's no remainder. So your remainder is 0. Okay. And there are multiple ways. You can take even 3. If you take 13 by 13, what will happen is you'll get this, it'll be the same thing. Okay. Here you go. All the thing. Now, when you divide 13 by 6, your quotient will give you 2. Generally, when you divide 13 by 6 by your long division, the upper part will give you 2, and you get the remainder of 1. That's the thing. Okay. So this is your operators and the data types. There's one data type left, which is called Boolean. Okay. So far, any doubts before we go into that part? No doubts? I can carry on. Okay then. So now for a Boolean, also if you want to comment it out, you can just do control slash and it'll all be commented out. If you don't want to see the code again, or if you want to type some notes, example, here's the next code. Thing is, it'll be really dark. You can't see the comment, but you can, it'll be a little bit visible. Okay. So these are the things that it won't execute. When you comment out a code, it won't execute. Okay. Now let's come to this part. Okay. So now the next topic is Boolean. Boolean is simple. Boolean is nothing but true or false. That's all. That's the only thing always you can keep in Boolean. So as I told you, generally you'll have a word or an integer or a float. That's all you'll be having. But even Boolean, it's not something we'll use in daily life. But in terms of programming language, we'll need it. Okay. So how to define Boolean? It's just bool. Bool is the thing. Okay. So um, let's take a simple example. We'll take is raining. So did it rain today? Yeah. Oh, here it rain in Chennai it rain. So if you feel that it rain, you can keep true. Okay. So what you're telling is, for a variable is raining, you're keeping it as true. Okay. Why do we need this? Later on, when we are doing some advanced topics, we will need to store these results. And generally, you can consider this as true or false as yes or no. So in case if you want to like find prime numbers, you want to store it in a result, you can tell true means yes, it is a prime number. False means no, it is not a prime number. We'll come to that example soon. Okay. Now let's take another example where you're telling that if it's snowed, it's snowing. In Chennai, it doesn't snow. So it's false. Okay. So if you want to print this, you won't see anything. You'll just see the same thing again. You'll just see it's raining. For it's raining, since it's true, it'll just show true. Or one. Okay. So what is true or one? Why is it showing one and not true? Because in terms of computers, you can consider true equals to one and false equals to 0. I'll just comment this out so that you can see probably. Okay, don't worry about the error. I'm just telling you that true means one and false means 0. Okay, so if you're going to print the Boolean variable as it is, it will give you the number. It will give the numerical value. It won't give the word true. Okay. So with this, what can we do? We can do all different Boolean examples. Example, you want to see if it is raining and snowing. Okay. If you want to see if it's raining and snowing. So what do we mean by telling if it is raining and snowing? It means we want it to rain. We have to check if it's raining as well as if it has to be snowing. Meaning you can do like this. So what does this mean is what I'm telling is I want to check if it's raining. So it's raining equals guys, can you see my screen?
Yes, I can able to see your screen.
Okay. Yeah. So it's raining is true, but it's raining is false. So only one of them is allowed. The other thing is not allowed. Okay, so only one of the thing is being true. But when I tell and, I mean that I want both of them to be true. The meaning of and is I want both of them to be true. Okay. So example, if I want it to rain and snow, I have to do is raining and is snowing. Both of them should be true. If one of them only is true and other is false, it should come as false. Okay. For example here, is raining is true, but it is not snowing. So in that case, this will give you false because only one of them is true. We are not getting both of them true. We need both of them to be true. Okay, so let's try this example out. And also notice that once I commented this code, you guys couldn't see the code. Okay, wait, my mistake. So when you're doing these stuffs, generally keep it in a bracket. Okay, like store key use this. If you're trying to print an operator within the function, just keep it in a bracket. It's a good way to like keep stuff. Okay. And yeah, and yeah, we can run now. So yeah, as I told you, when I mean and, I mean both should be true. Only if both are true, it will work. Okay. So now if I change both of them to be true, now it will be fine. It will show you one. You can keep like a table and check with different combinations. The only case it will give you one is when both are true. And this can extend up to all different types. So I can make like bool is raining, snowing, freezing. Okay. So then we name this as false. Now here, what happens is when I give something real, I'm telling it to be, it should rain, this should be true, and this should be true, as well as this should be true. All the three should be true. What is the symbol after is raining? Okay. So a symbol after is raining is and. Oh, okay, yeah, that's it. Good job. And it's actually above your 7. No, actually, there'll be a small problem because you should not keep an operator while printing it. Don't do it. If you want, first compile it within the bracket, then you do. That will work. Okay. So when I mean here and this, I mean it should be raining, and it should be snowing, and it should be freezing. Only if all of these three conditions satisfy, it will print 1, or else it will print 0. So let's try this out. Okay. Yeah. So you get 0 over here. Okay. Now if I want only if all of them are true, it will work. Right? So you can try this. So here it's 1. Okay. So generally, this is the thing. So and is that's the concept and means it should work only if both the operators are working. So example here, when I mean this and I mean the one on the right should be true and the one on the left should be true. Okay. But what's there on the left? On the left, again, you see another and. So what's the meaning for this one? This and is asking you to be true on this side as well as on this side. So since all the three are true, it's giving you true. Even if one was false, it won't work. Okay. That's one thing. Now, let's take another case. Let's take another case where either this or that type of case. Okay. So let's take example. We can take something related to college. Is attending. Okay. So is attending is true. And bunking. I don't think any of you guys will be doing. Okay. So is attending is true and bunking. So now here we're going for a new operator called or. Okay. So what I want to see is I want to see if someone is attending or is bunking. Now, what's the difference between this and this? Here, what I'm asking you to do is I'm just saying take a random student, check if he's attending or if he's bunking. In case if he's attending, it's okay. If he's bunking, also it's fine. I want you to make sure that one of them at least is true. I don't want any other case. I don't want a case like he's neither attending nor he's neither bunking. Then we're kidding. There's no case like that. Okay. So if you guys are finding confusing, you can take another case. It's winter and it's summer. Okay. So in this case, either to be winter or either to be summer. If it's none of those, then it's a problem, right? So either of them if it works, it's fine. If it is winter's true, it's okay. Even if it's summer's true, it's okay. So here in this case, one is true and other is false, which is fine. So yeah. So what you can do is okay. So you're getting the previous one. So if you don't want to see this again, just comment it out. Press Ctrl/ to comment it out. Or you can type manually 2 slashes under start. Okay. But yeah, now you can see that it's one, meaning one of them is true. That's all you can say. You can tell, yeah, you may not know which is true, but you can tell at least one of them is true. Okay. So even if both are true, it's fine. If it's both summer and winter, it's fine. Even this is gonna work. Okay. Even then in this case, it's working because either one of them is true, at least one is true. Okay. When will it not work? When this is false, as well as this is false. Okay. So we can take this example. False, then this false. So here you can see that this is also false, and so neither of them is working. Only because both of them are false. Not even one is true. So therefore, that case is giving 0. Now, why am I telling all this? Because you will be needing to use this in other places. Alright. So uh, that's all is for your data types and operators. Now let's come back to the original question. Why are we even storing variables? Like, what's the point even? Why do we even have to do all this stuff? So let's take a simple case. Let's take this one for example. As I told you, you can directly print it. You can directly print what's 5 into 3. You can do 5 into 3 like this. Okay. You can do like this and it'll all work fine. For example, we can run this and check. Yeah. So 5 into 3 is 15. But the problem is, take a case like this where you have to first show the sum, then you have to show the subtraction, then you have to show the multiplication, then division and remainder. In these type of cases, at first you can type it out. You can type 5 into 5 plus 3, then 5 minus 3. You can keep doing like that. But suddenly if I ask you to change the number, example, now I keep another thing where I do 5 divided by 3. And I keep going on like this. No, the problem is, now if I want to change all the 5s to 6, then for each every time I have to do 6. I have to keep changing each of the 5s with 6. Okay, that's a problem. That's hectic. You have to keep changing each place wherever you can find every place that you keep. So for that case only, we are storing things in a variable. So here, if I want to change the number, simple. I just have to change it one time. Compared to the previous time where I had to keep changing each different line, here I'm changing all in one go. Got it? That's the whole reason of variable. Variable is just to store because you feel that you may need to use it later on for other part of the code. That's all is a variable. Okay. And this is your data type. And so far I've been only printing stuff and I didn't teach you input part late because that's reserved for later. So that's it, guys. Any doubts so far? Oh, okay. Yeah. Ganesh, you told it correct. Yeah, control/. Okay, that will come in through. Okay, then. So yeah, we'll be moving to Nitin. You can carry on. Bro, don't call me sir, please. I'm just a third year student. Okay. Nitin, you there?
Yeah.
Oh, that's it. Okay, yeah,
Rohit,
continue.
for covering.
Yes.
Thank you, Rohit, for covering all the basics of C++. I hope everyone was able to follow along. Are there any doubts that need to be addressed? Now I invite Nitin to take the session forward.
So, hello guys. Let me share my PPT first. Just 1 minute. Rohit, you can stop sharing your screen. This one. So I'm going to cover a part how to take input output, how to take input and how to print your output in your screen, and how the basic structure of C++ looks like more in detail, as Rohit has also covered, but a little more in detail. So, this is- so guys, if you have not already joined our Instagram page, you can scan this code and Abdul Wari is coming. So let's start with the basic structure of C++ code. First, as you already know how your C++ code will look like, as Rohit has already taught you. First, we include our header file. Why we include our header? The header file provides us so many functionalities that to use in your C++ code. Like someone was asking IOStream. The IOStream is a header file you use to, if you want to take input output, you include IOStream. And there are many other libraries like algorithm to use sorting methods and many other string functions. But to use your C in and C out, you have to include it IOStream, or you can include bit slash std C++ was Rohit was included. That includes everything, IOStream, your any other required libraries. And for the second line, using namespace std, I will talk about while coding. And here we have our main code. Our main code starts from here. If we run this code, this starts from inside this main block. Here we first declare what the return type, and we write it as a main and then two brackets, and we start coding inside these curly braces. This is the main code. You have to remember and just remember it, because you have to follow it every time. Include std stream, then using namespace std, then you have int main and the curly braces. No need to return zero every time. This is a function, and we have this int as a return data type. So we are returning as a zero, which is a int, but no need to return inside a main. It's not compulsory. Let's talk about more about input and output. How does we interact with our program? We need to give input and get them some out. That's why we are writing a program. So have you already taught this? And it provides a C in. It's for input, C out for output, and there's a C log and C error. We are not going to discuss about it. It's not important. So I'm going to share my screen for VS Code for coding. So let's start first by creating a file named demo2.cpp. You can give any other names, and CPP is your extension for all the C++ files. First, we start by including IOStream, which is our header file to use input output scene and cout, and then using namespace. Let's first not include it. I will tell why we include it after that. And there we have, so someone raise your hand, yeah. You have any doubt? Do we need to always write main? Yeah, it's important. Yeah, we have to write it. It's like a function. We are writing a return type, then there's a name of the function which is main, and we tell when we execute, we tell you have to start inside the main. Otherwise, every code inside starts in main only. Means if it's written outside the main, then it will not execute first. The first thing it will execute the main, what's written inside the main function. And yeah, you have to write it like this every time. Let's say you are initializing any variable, let's say a, and first talk about cout. This you have to use. This is showing error. Why this is showing error? For this, it's not understanding the cout. We have to tell we are using a standard library, which is inside the IOStream. So IOStream inside a standard library, and we have to tell we are using a standard library. So every time you are using cout, you have to write it like this: cout a or cout hello. So if you don't want to write it std every time, so you can just include using namespace std at starting. That's why it is used. If you remove with std, now it will not show any error. So now your error is gone. If we not include this, then you have to write it like this. That's all why it's used for. To know, you have not to write every time std when using cout or scene. So as Rohit has already taught about the cout, let's more focus on the input part. That is in. We are using extraction. This is called this is your operator called extraction operator, and this is cin to take input. If you have declared a variable called a, then you want to take input from user. What we should keep the value of a. Let's say first cout enter the, and every time you write any line, you have to end it with the semicolon. It's for C++, Java, and C also, not in Python. So let's take input as A, and let's print out it also after taking an input. And for input, let's give the focus. So let's run it. I'm using extension called code runner. You can run and compile and run it directly from a terminal also. So let's give the 67, and there we go. We are storing we are taking input from directly from our terminal. And now I'm going this is the same way you to take input, or if you want to take input string, or if you want to take input a double, let's say double or float, what we call float also, it's double. anything, any data type, we have to use just simply cin, and that okay, so I have to use it variable name different for all the data types. Same here. So you have to just write cin, and at the after that you have to just write its variable name. Just say cin or you can say cin as fourth string also, say in F fourth float, or C in an A fourth string, like this only. You can give any type of input for this. Let's say first I'm giving input D, which is double, means it's float, similar to float. Or float is this. Then we are giving, oh sorry, string. Just wait, wait. First we are taking input as a double, so skip the 7. And then we are strings, and let's say, and float we have 7.8 and the string 6. Just simply you can give just writing by C and then extraction operator, that is greater than 2 times, and the name of the variable. So you have to click enter every time you entering the values. If you want to take input in one line, just like let's give you one, just A, B, C. Yes, I'm declaring the ABC int in one line. You can hit also, or you can just keep it in every different line, but it's faster if you are using. So you can declare it in one line, these 3 variables, and you want to take input. So you can just do as what you are doing with the cout, writing 3 in a one line also. Just use this extraction operator, then the variable name, then the section operator again, then the variable name, and the section operator and the variable. To give output this, you can let's print out also after taking the input. So put space between after. So let's run it. Now you can give an input by in 2 ways. You can just give a give input for A, then B, then C after pressing enter, or you can just give it in a one line also. Pressing the space button 3, 5, or 6. It will take first as A, and after space it will consider another input B and then C. You can just give it by input by space and you will get the answer also. So let's to talk about more about string. Let's say you want to take a string as in, so you can simply just see it. So that is also works in the same way. This and this. S1 or S2. Sorry. And print, let's print out also S1 is S2. Our string is, let's say, decode, and let's say for S2 we have DS. So printed, we got DSA. But what if you want to take a sentence as an input? Means you want to take store S1 like as a decode DSA. You want to store in one variable. You have to take a sentence as a string. Let's say my name is. You want to store my name is Nitin. But if you normally do it, if you normally do it, say in just declare one string, and if you normally do it, sorry, I'm using different. So let's give input decode DSA to S3. So what we got only the DSA as output. We gave as input as a decode DSA, but we are just getting the here, but getting the decode stored in the S3. Why it's there? Because we are putting a space. The space, the compiler things are giving a two different inputs. So it is not storing in S3 and is thinking that it's different input and there's no different. I'm not taking any input after, so it's just storing the decode only. What if you want to store any sentence? So you can just use a method called get line. Let's say get line C in and then the variable that is C in. Yeah. And let's also print out after this. This one. So take input my name is C. So now you're getting a full string. If you are not using a get line, then you will just get, let's say, again, I'm S1. If you not use get line, if you use a C normally, then it will be only storing the first string. Just like this is storing just mine. So that was basic scene, say out input output part. If you guys have any doubt for this, you can ask me. If you guys have any doubt about the input output part or any basic structure, even for multiple lines for the same variable. What about what about multiple lines for the same variable? Can you explain your doubt clearly? I'm not getting it. Episode GS. Find a string without a cout. The string is not printed, right? If we define a string without cout, the string is not printed, right? What does the get like? Okay. I'm explaining it again. Okay, the double is like a float only. The you can give decimal values, just the similar, but there's a size difference inside. There's no need to worry about that. Para in an input for a variable, how we will do. Okay. I'm now explaining how why we are using a get line again. Let me share my. Okay, why we are using a get line? I'm explaining it again. Don't worry. So if you want to take para as an input or a line as an input, you need to use the get line. Why we are not using cin? If we are using cin, if we give input, wait, if we give input any, let's say if my name is this something, then we while giving an input, we are using space. For a cin, if we use a space, it's considered as a different. It's considered the first input, then it considered as a second input, then it considered as a consider as a third input. If we put a space between each string, it will consider as a each different string. But for a get line, let's what will be the output for this? I'm just taking the first S1 as a input because it's considered the first as the first input and stored it in a S1. And if we put let's say S2 here and give the same output, this print also S2. So the same thing I'm writing. Here we are storing the two my and then after the second word in the S2. And we are ignoring the other parts because we are not taking input any after that. So first store get stored in S1, then after that G something that is stored got stored in a S2 only. But what you want to store everything in one line or any line or any paragraph to store in one variable only. So you use getLine for this. What getLine does, just it takes the all the inputs until you press any enter button. Means after it will store my and this full sentence. Then after that we press enter, so it will stop taking input after that and will store it in the S1 only. So let's print out. And you can store a paragraph in using a getLine also. So you have to use a spaces and full stop. You don't have to use any press any enter button. Otherwise, it will consider as a different input. Yes, you can run it again. My name is Nitin, and it will print it full. If we were using a scene, then it will only store my because it considered the space as a four different input. And for getLine, it considered only consider a enter. So if you guys has any book left, then you can ask again. Well, generally we use shift enter to go on a next line. Would that let's check it out. Yeah, pressing no, just shift enter is like enter only. You don't have to use shift enter. It's just it works for just like enter if you are using and shift enter also. I'm pressing the same. You can try if you want. Is there any option to do normal division in C++? Okay, okay. So while doing division, we were storing just the integer part only. Just say int A, int B. So it, we give 6, and here we are giving 5. Then if we print out A slash B, and then what it, yeah. So it's printing 1, but you want a normal division, means you wanted a value in a float or 1 point after decimal also, right? So you can use these. What is it exactly doing? It's A is integer and B is also integer. So C++ automatically converts the output in an integer, means its value can be anything. It value can be 1 point something something, let's say. And then it is just storing the first because we are taking both these values are integer only, so it's storing as integer. But if we use any of it as a float, so it will not do typecasting. What was it was doing before? It was doing a typecasting, means it's storing the float value creating a float value into integer, converting it. But now let's check it out what it will do. Now you are getting 1.334. So you have to use the one value as a float and another value as a int, or you have to use like this both the values. If you are using int values every time, then you can just typecast here. This is called typecasting. You are converting the int value into float to print it like this or to work it like this. Just it's working similarly. So any other doubts? Yes. So how did we define a string value in C? Okay, you are. So that is from me, guys. If you have doubt regarding to input output, you can ask me. Otherwise, we can move to the next part.
Thanks a lot, Nitin, for walking us through the key topics of C++. I believe everyone found it insightful. Does anyone have any questions or points for clarification? And with that, we conclude the first half of this session. Take a short break and join us after 10 minutes. Be on time. You wouldn't want to miss the amazing second half we have planned.
Hello, everyone. Before we resume the session, hope you all have registered in the Event Hub section so that you could receive your certificates for this event. Welcome back, everyone. And hi there, this is Darshini. Hope you had a nice break and all set to continue. I call upon Rohit to guide us through the basic of the loops.
So hi guys, welcome back. You guys welcome back to me. Okay. So now that you know about your basics, we are going little bit higher. And so I want you all to buckle up, put in a seatbelt because you're going on a fun roller coaster ride. Okay. So we're going to go, we'll start with simple term. Let's start with a thing called conditional operators. Not operators, operators we saw already. Conditional statements. Okay. Okay. So um, I hope Nitin has explained enough about the input part because we are going to use inputs and outputs extensively over here. Okay. So what so far we did addition, subtraction, we did all the math stuff. But is that all coding is? Like, can we just do addition, subtraction, just make the whole thing? No, we need some more. We need some places where we need to use logic. We need to take a decision. That's the whole idea of this whole coding thing. Okay. So how do we take decision? With this thing called conditional statements. Okay. So example, I hope you guys can see my screen. Over here, let's take a variable int x equals to 5. Okay. And now what I want to do is I want to check if x is greater than 5. Only if x is greater than 5, it should print something. Or else it should not. This type of questions where I'm telling only if or I'm giving some condition, those are called conditional statements. Okay. So how do I type that thing? Simple. If x should be greater than 5. Okay. Then what should you do? You can print something. You should print. Alright. Let's print like that. Okay. That. Okay. So now what I told you, I told first I define x is 5. And after that, I'm again keeping if condition to check if x is greater than 5. Now always you're going to get like this. Some places you may get it as an input. So we'll come to that part later. Now we'll focus on this. So now we know that the value of x is 5. We know that for sure. So there's no problem. So now the next problem is when we come to this line, it has to check if this is working, if this is true. So to check if it's true, you have to substitute 5 over here. It is just 5. You don't have to substitute directly in your mind. It is substitute. So is 5 greater than 5? Like think what is how can a numbers be greater than the same number? Is it possible? No. You can't have 3 greater than 3. It's not like there's one 3 that is greater than another 3. That's not possible. So this case is same as you telling it's false. So this whole thing, if you evaluate, it is false. What's the purpose of the curly bracket? Yes. We'll come to this part soon. We'll first finish the rounded bracket, then come to the curly bracket. You see, it's like a symbolization that the curl is going to make it messier. So let's first make the smooth ones, then come to the messy part. Okay, so this means it's going to be false. Okay, now let's check about 6. Let's take 10 for example. Better. Now let's just visualize. So I'm going to now I'm finished line 6 and I'm coming to line 7. Line 7 is a conditional. I don't know what the condition should do. I don't know anything. But all I know is x should be greater than 5. That's the condition. So here x is 10. We know the x is 10. So 10 should be greater than 5. Is 10 greater than 5? Yes, it is greater than 5. Okay. Let's take another case where it is less than 5. Take this for example. Now let's take some random number. Let's take minus 20. So it's now minus 20 greater than 5? No, it's not greater than 5. It is less than 5. So again, this is false. Okay, that's what is this for. This part, it will just check if it's true or false. That's all is this rounded part for. This rounded bracket will check if the thing that you told, if the condition is true or false. That's what is this one. Now let's come to this curly bracket. The whole idea of this if statement is, if this condition in this rounded part is true, it has to execute all the lines that is in the curly bracket. Okay, again, if it is true over here in this rounded bracket, then all the code inside the mess in the curly bracket should be true. Okay, so what's the thing is it? So in case of this, minus 20 is not greater than 5. So this is false. As I told, only if it's true, this code inside the curly bracket will run. Okay. So now coming to your doubt, why are we using a curly bracket? To segregate, to show that these codes belong to the conditional statement. This is not a normal code. See, a normal code will just be something outside. It look like this. This is your normal code. This is different and this is different. This will run only if your value of x is greater than 5. But this will run for all cases. The only way I can segregate both of them is to keep this inside one variable. It's to like split it up. It's like to tell that this is one chunk of things that should happen when it is true. If it's not true, you can leave it as it is. Okay. So now let's run the statement and check. So yeah, we'll just go run code. Okay. Yeah. So you got directly by. So what happened? So you told that x is 20 minus 20, and you're checking the if condition. Substitute minus 20 with x. You're getting minus 20 is less than x, and minus 20 is greater than 5. No, minus 20 is not greater than 5. So anything inside this code won't run. For even that fact, I can even do this. Even this won't work. None of the statement inside this curly bracket won't work. You can just simulate, you can just see that all the things inside this, it's not going to work. That's all his idea. Okay, so again, for the same case, we can take this. Now again, when we run, it's not going to work. It's just going to print directly. What's happening is, it's skipping this part. It's like, okay, this is false. I'm going to skip this part. I'm going to directly go to the next part, which is written by. Okay. What about a case where it works? We'll take 10. Okay. So when you want to, all you have to do is, if this is, so 10 is greater than 5. So when 10 is greater than 5, before it runs these function, it will run these two functions. It'll run everything inside the curly bracket. Okay. So let's see how run. See? So it will print hi, it will print hello world, then only it will print by. So it'll run all the things inside, then only it'll come here. That's what it's if about. Okay. So how is this useful for us? Simple. Let's take an example where we're going to use a CGPA. So CGPA is a floating value. So let's use float. Okay. Let's take from the input. Let's take from the input. So C in, then this operator, CGPA. Okay. Now, generally VAT, we have a condition where if your CGPA is greater than 9, you don't have to worry about attendance. Attendance is not a problem. So let's check if our CGPA is greater than 9. So for that, do if inside that you can keep CGPA to be greater than 9. So greater than, it can be greater than or equal. There's both chances. So in case of greater than or equal, so keep this alligator bracket and equal. Okay. You guys will see it as a normal thing. You guys will see it as like this. I just kept an extension. So you'll get like that. Okay. So keep a greater than or equal. I'll just post it in chart once. Okay. It'll look like this. Okay. That's the thing of greater than equal. Okay. So if it's greater than or equal to 9.00, then it's free attendance. I mean, no attendance. No attendance. Okay. Okay. So let's run the code. Running the code. It'll wait. So we can enter Nova CGPA. So let's tell that we got 9.2. Okay, hold on. Okay. We go back to this thing. Okay. Yeah. So it'll compile. Hold on. Return 0. Okay, that's one more new thing. You will see, so you'll soon see it. Yeah, we'll go with this. You'll see it soon, don't worry. What's the use of it? That's a complete topic on that. Mm, hold on. Yeah. Okay. And yeah. Expected time, it will end around 10:30 because we have some more little more to cover. But yeah, we'll wrap it up at 10:30. No worries. Okay. So yeah, now let's enter input. So let's say that we got 9.23. Okay. You don't have to worry about attendance. So no attendance means you don't have to worry about attendance. Okay. Um, let's try another case where we have to just give some, we'll give something below. Example, we got 4.56. Okay. Here nothing happens because after the if statement, there's nothing else to do. It directly finishes the program. So there's nothing else, so it prints nothing. But what do we want to do if what do we have to do in case if this is not the case, it has to do something else. In that case, we can type else. So all it is, if this is true, it will do this it will do this chunk of code, or else it will do another chunk of code. Okay. So attendance is needed. How is this different from writing this outside the line? If you write this outside the line, if you write it here, this will happen always. This is going to happen always. The one inside this if and else won't happen always. Okay, so now we can try. So now if we try 4.56, it'll print attendance needed as well as it'll print always. Here it won't print no attendance because this is false. If something is false, it will go through else part. That's it. That's the idea. But what if you have more conditions? Like if it's above 9, no attendance. If it's above 8, it's good. If you have a CGPA above 8, it's good. Something like that. In that type of case, what should we do? Simple. Again, you have to end the bracket. And if this is the case, it goes. Or else, again, you have to check the next thing. So if CGPA, that is now, it's above 8, means it should be below 9. It should be below 9 and above it. That's the idea. So through below 9.00. And there are two conditions. One, it should be below 9 CGPA and it should be greater than 8 CGPA. Okay. So and 8 CGPA. So you see that the logical operator is coming back. Okay, there's an extra line created. Yeah. Okay. So how does it work is first it'll check the CGPA. It will check if CGPA is greater than 9. If it's greater than 9, no attendance. In case if the CGPA is less than 9, it'll come to this part. But in this part again there's an if condition. This if condition is if CGPA is less than 9 and it's greater than 8, then you can print another statement here. We can print here, keep it up. Okay. Okay. So even after all of these statements all fail, only the last attendance will needed will be coming up. Only when the CGPA is below 8, this is going to come up. For that example, we'll try to. So let's say we already saw the 9 and less than, but let's see what about the thing in middle. So let's say 8.5. Okay. So this has failed. It is printed not this part is failed because 8.5 is not greater than 9. So this part is failed. It comes here. 8.5 is less than 9, which is true. And 8.5 is greater than 8, which is also true. Since both of these are true, it will print only this. You don't have to worry about what is happening after it. If this is true, this will run. That's it. If this is true, this will run. So it will do keep it up. And as usual, always will be printed nevertheless of the statements. Okay, that's the idea. So typing like this. Now we can even make one more. We can even check if they're in 7, if they're between 8 and 7. The same condition, CGPA less than 8 and CGPA greater than 7. Okay. Again, you can type like improvement. Okay. So now what will happen? If it's not between the range 8 and 9, if it's not between the range 7 and 8, I mean, if it's in the range between 7 and 8, then in that case, a print improvement needed. So let's try for all different examples. Okay. Yeah, there you can set. So let's try all different examples. First, let's take an example where the CGPA is about 9. So let's take 9.8. Okay. So no attendance. Good. Now let's take another case where it's between 9 and 8, which will be 8.7. Keep it up. You see that another other lines work. Only that particular line works. Okay. Then the next thing. Now again, now we have to type something in middle. So we'll keep 7.9. Let's just say that by point one day couldn't get 8. So it's okay. So improvement needed. Now let's take the last case where it's less than 7. So you can take any number. So you can take 5.06, something like that. Attendance is needed. So is it like how we first started if, then we went with else, then we went with if, else, if, like that we're going in. So it's actually a ladder. Like first you're going top, then you're going to the next part, then you're going to the next step. So it's an else. So like this is called if and else ladder. Okay. This is one thing. Okay. So generally, if you want a logical statement, this is a good way. I have an exercise for you guys. So given three numbers, int A, B, C, I'll get the input from you, okay? I'll get the input from user. Okay. Now what I want you to do is, I want you to print the maximum number. Okay. So see here, max. Okay. Then I do this. You can print directly the number. How to do that? You have to use your if and else statements to get that done. Okay. This is your homework. Try it out. You can use if and else ladder and get it done. Got it? So with this, you will know a good grasp of how if and else works. Now let's go to the next part, for loops. Okay. So for loop is simple. Let's say that you're getting a number n, and I want you to print all the numbers from 1 to n. So how can we do that? Using if statement we can do. So if they tell if n is equal 1. Okay, yeah, again. Oh, assignment. Assignment is okay. I'll just give here. So you can take three inputs, given three inputs, A, B, C. Okay. Take the print the maximum. Print the maximum using if and else. Maximum using if and else. So what you can do is first you can check if A is greater than B and C, because only if A is greater than B and A is greater than C, you can tell that A is the maximum. So like that you can do each step. You'll get an idea. Okay. So try this. Don't take a assignment, just a homework, just a try. Just you can think of it. Okay. So you're coming back. So now if I want to print 1 to n, what should I do? I should do if n is equal to 1, then print C in this 1 comma 1. That's all. This is the thing. Then if n is equal to 2, else if n is equal to 2, then I have to do C in 2. I have to do 1 space 2, then I have to do this. Okay, it's C out, sorry, my bad. Yeah. Okay. If n is equal to 3, I have to again do this. So if you see, you can't get the proper, it will keep going on forever. You can't tell what is the maximum in. It can keep going on forever. So using if loop to get this done is not going to work. So the other way is to use a thing called for loop. So how to do for loop is for in bracket, first declare a variable. So here you're declaring a variable called I. I is called an iterator. Okay. This is only going to be the value. This value is going to store the current value of the range. So now I'm telling that if I want to print from 1 to n, I have to store a current value of range. So here it's starting from 1. The current path is 1. Okay. And it has to go up till n. So I should go up till n, meaning I can be less than or equal to n. Okay. And I plus plus. Right? So how this is going to work is I'm setting an iterator I, which is starting from 1, and it will go all the way till n, and it'll And why I'm not keeping I equal 10 and why I keep I less than equal 10 is because I should be less than. Only when it's less than n, it will print. So example, take n equals to 10. So it should print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. After 10, when it becomes 11, 11 is not great, 11 is not less than 10. So in that case, we have to break out of it. We have to come out of the statement. That's the reason why we're giving less than or equal to. Okay. That's what is this part is. So this part is declaration. This part is like a condition. You have to make sure that it's within the range. The only way to make it sure it's within the range is to check if the iterate is always less than equal to n. What about this part? I plus plus. Nothing. I plus plus means your your current thing should go to the next number. So here example, if I is 1, the next number is 2, right? So it should add one more thing. The other way to do is you can tell I should be I plus 1. Now actually all the math people you'll get surprised. You can't how can you keep I equals I plus 1? I and I will get cancelled, you get 0 equals 1. No, no, no. Here what this means is it means first your I was first your I take I is 0. Now I'm getting the new I to be the previous I plus 1. That's what this means. This means this is not the same I as it is. It's telling the one on your left hand side is your newer version of I, and the one on the I on the right hand side is the older version of I. So if I was 5, after you run the statement, I will become 6. Because how will it be is I equals the previous version of I was 5. So 5 plus 1, 6. So I equals to 6. So now your current, before your current point, iterate was at 5. Now your iterate is 6. Okay. So that's the thing. Now how do we use this? It is again a variable. I is just a variable. See, you can, it's just a normal variable. You can directly use it. So C out, then your normal thing. I, and then, yeah, let's just keep like this. Let's see how it goes. Okay. Now let's run and check. Okay. Now let's keep 10. So it has printed a series. It has printed first, it has printed 1. So what this means is your I was 1. Then I became 2. Is 2 less than 10? No. 2, yeah, I mean, yeah, 2 is less than 10. 3 is also less than 10. 4 is less than 10. 5 is less than 10. 6 is less than 10. So on till 10. 10 is less than or equal to 10. Because we get less than or equal to 10. That's the thing here. So it is less than or equal and go. Now next what will happen is 10 will become 11. When it becomes 11, 11 is no longer less than n. 11 is no longer less than 10. So for that case, it'll stop printing. This whole thing that you see again in this curly bracket will stop running. Okay. That's the thing over here. Okay. So, yeah, that's the thing. So what can we do with this? We can try something else. Let's tell that we want to print only the even part. We want to print only the odd numbers. From 1 to n, only the odd numbers. So I want 1, 3, 5, 7, 9, like that's all. So as I told you, here you can change it. Before it goes to the next operator, to go to the next iterator, you just add 1, no? Now here it add 2. Because first it is 1, then it's becoming 3. So if you see the arithmetic difference, it is 2. So you can do I equals to I plus 2. You get it? It's like a normal geometry, not geometry, arithmetic progression. Your D is the thing that you mentioned here. Okay. And again, if you find this troublesome, another way to do is I plus equal to the number. The number, any number it can be. It can be any number. So here, for example, it'd be I plus equal to 2. So we can either go with this way or we can go with I plus equal to 2. Anything will work. Okay. Initially, I showed you plus plus. That's nothing. That's just a special case of I plus equal to 1. Okay. So there are lots of ways to tell. So, so generally, you can tell I equals to I plus 1, or you can tell I plus equal to 1, or you can tell I plus plus. Okay. There are multiple ways for a case of a 1 alone, there's multiple case. But in case of 2, only these two will work. This I plus plus won't work. It won't be like, you can't do like I plus 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 plus. This won't work. Okay. So don't try this. Go with any of this. So let's go with this. Okay. So now what this will do is, first it will check 1. Okay. Then it'll add up 2 to that 1, which will make it 3. So it'll print 3. 3 is less than 10. It'll print 3. Then it'll add 2 again, become 5. 5 less than 10, yes. It'll keep going on, so on, so on, so on. Okay. We'll done and check. Okay. Now let's enter something like 20. So you see there's no gap in between. So when I told when there's a gap, when you need a gap, just keep a space. Okay. So that'll be more clear for you guys. Do this. And now if you do this, you can see that all are odd. So first your I was 1, then your I is 3, then 5. So it's like a arithmetic progression. My bad. Okay. So that's for your odd part. Now, you guys will think about even part. So for even, what should it be? Even generally it should start from 2 onwards, right? Because the first even number is 2. So your first number should be 2, right? So you should, instead of keeping I equals to 1, you keep I equals to 2. Okay, so you can do that. And then you can again print 20. But this time we print all the even numbers. Okay. Any doubts so far? With okay, Ritin has been answering. Nice. The conditions and procedure to be done in for loop cannot be written in multiple sentences. No, you keep all in one sentence. Yes, you do keep all in one sentence. On my value, like in new line 1, then in new line 2, then in new. Oh, okay. You want to print it vertically. Okay. So simple. No, I want it to be in a new line. You told the answer. Okay, just in the C plus term, it's end L. Okay, so you can do end L. End L is just going to push it to the next line. That's it. Okay. So let's try that now. Yeah. Now let's print 20. It has printed everything in a new line. So how it is doing is it's printing 2, then it's going to the next line, printing 4, going to the next line, and going on so on. That's the idea. Okay. So this is your for loop. The use case of for loop is a lot. But there'll be sometimes where we want to keep where we'll need to keep a stop. Example, tell that I'm giving some large number like 100. But obviously, if I press this 100 here, it's going to be problem. If I tell 100, it's going to print all the numbers. Okay. It may print all the numbers. If I go for larger number, it'll be problem. So let's say that I want to limit this case. I don't want it to go like a lot. So in that case, what you can do is let's keep the upper limit is 20. So even if the user enters 100, it'll go only up till 20. How to do that is if when it's becoming 20, so you can tell it like if I is going above 20. So you have to see the case where it is getting a problem. So when I is greater than 20, greater than 20, then in that case, you should stop. So to stop this whole loop from going a lot, you have to use this thing called break. So what will happen is, even if the user mentions like 10,000 or something, it won't go up till 10,000. Okay, just for an example, I'll write here. I'll try this out here. Okay, it has printed all the numbers till 10,000, but I wanted to stop before 20. So for that case, you can use this if loop. So let's try to compile and see. Okay, so now again I'm entering 10,000. I'll go a little bit higher. That's all. I'll make the highest. So now, even though I kept a really high number, after 20, I told it to break. Once it becomes 20, I told it to break. Okay, so if I is now when it's 20, when I is 20, 20 less than 20 is false, so nothing happened. But next number I was 22. When it becomes 22, 22 is greater than 20, which is true. Since this is true, whatever condition goes here also will be, whatever statement goes inside also will be true. So if you ask it to break, it'll break or it'll follow. The follow won't run anymore. So after 20 won't see any other values. Okay. Whatever a case where we ask before 20, like tell like we did 15. We can try that as well. Here. So here we print the 2, 4 like that and till 14 only. Even though we didn't reach 20 also, it didn't do. Why am I telling this is because some may just tell get the input and just keep printed from 2 to 20. Just do that because we are told upper limit is 20. Let's just keep like that always. But the case is that problem is if you do like this, if I compare and see, even if I print 15, it's printing up to 20. But no, I don't want it. I wanted to print up till 15. I want to print all even numbers up till 15. That's the case why I keep this. So that even if it's less than 20, there's no problem. Only when it's greater than 20, it should break. That's the idea of this whole condition. Okay. Uh, so yeah. This is the for loop part. Now final one exercise is let's print all the prime numbers. Okay. So to print all to check if a number is prime, you'll need to do one thing. You'll just need to know one concept. To check if a number n is prime, none of the numbers in between 1 to n should be divisible by that. I mean, yeah. For example, take 7. So numbers between 2 to 7, there's no number that can divide 7. But if you take example 10, 2 can divide 10, 5 can divide 10, 6 can also divide 10. That's 2 and 5. Sorry, my bad. 2 and 5 can divide 10. Okay. So all we have to do is we have to check if it's not if it's dividing, it's not a prime number. If it is not dividing, it will be a prime number. So for that case, we'll go with the same thing. So we'll go from it. We know that the first prime number is 2. So we'll start from 2 and we'll go up till n. And let's just do I plus plus because it has to try each and every number from 2 to n. Now what condition I told is if it's divisible, if this number I is divisible by n, in that case it's not a prime number. So how to do that is if when I tell divisible, it means remainder should be 0. So let's use a remainder of the operator. In mod I, so when I'm dividing n by I, it should always be 0. If it's 0, then it means it's divisible, meaning this number is not a prime number. This can't be a prime number because it has a factor. Okay. So we can tell that it's not a prime number. Not a prime. But what if it is a prime? Then in that case, I can do like this. Okay. That's an error. I'll come to this soon. Let's do like this. Okay. Let's do. If it is divisible, it should be not a prime. If it is not, it's a prime. Okay, let's try this. Let's run. Let's do. So now let's enter something like 7. So it has printed prime, prime, prime 7 times. Not 7 times. It has printed 5 times. But I want to print it only once. Why is it printing like that? We have to debug. So what do we tell? We tell I equals 2. So 7 more 2, 0, no. So it's printing prime once. Then it's going to 3. Is 7 more 3, 0? No. So again, it's printing prime. So it's every time it's printing it. We don't want like that. We want to print it only once. So this shouldn't go here. This should come somewhere else. We'll come to that part later. Now let's take another part where this is a composite number. Take example 8. Again, there's an issue here. First, it is printing not prime. Then again, it's printing prime. Why? Because when I is 2, 8 more 2 is giving you 0. Then when I is 3, 8 more 3 is not giving you 0. So it's printing prime. But we just, even if one thing works also, it's enough, right? So what you should do is, after you do the not a prime, you should break. That's the idea of break. Break is, you have to stop, you have to halt. You already found one multiple that may make it a prime. So you should break it there. So now if you do like this, if we try again, oh, okay, I didn't compare it with. You have to compare it, guys. Okay, now let's again try. So first number 2 and it worked. Okay, does it work for every case? Not really. If you press 9, 9 is a composite number, but first it will print prime, then it will print not the prime. So what's the problem? So now again, if we debug, first your I was 2. So n 9 mod 2, 9 is not divisible by 2. So it's printing prime. So the problem is we're keeping else in the wrong statement. We're keeping this print of prime in the wrong place. When we should keep print equal to prime is when even after trying all the numbers, you're not reached this type of condition. That's the case, you have to keep like this. So for that, what you have to do is let's remove it here. Instead of doing all this, let's maintain one liability, like something that will keep a track of it. So let's call this as flag. Okay. So what flag will do is flag will check if there's a prime or not. Here's the reason. Here's why we're going to. So if it's a prime, it'll be true. Okay. If it's not a prime, it will be false. Okay. So initially, let's just consider all numbers are prime. Okay. Why you consider all numbers are prime? Because we are not yet found if there's a divisor between the numbers between 2 and n. We are not found if if there's something that divides. So, so we'll just consider initially everything is a prime number. So now when it comes here, we have found that this number is no longer prime number. So what we should do is we should do flag equals to false. It's no longer prime number. You should keep it false. Okay. Now after the for loop end, if it's not the prime, if it is a prime number, then this break wouldn't have happened. This false also wouldn't have happened. So what will happen? Flag will still be true only. Even after the whole for loop ends, the flag would have been only true still. So now what's the useful of this? We can tell if flag equal true, we can print this is a prime. Okay. Take some time to observe. Meanwhile, I'll just run this code. Okay, so now let's try with 9 first. So first 9, not the prime, we know. So what's happening? First, it will check with 2. So 9 is not divisible by 2, no problem. Next, it will become I will be 3. 9 divisible by 3 is true. 9 is divisible by 3. So since this is true, this all will run. So what will happen? First it will print not a prime. First it will immediately print it's not a prime number. Then it says flag equals false. Why flag equals false? Because it is no longer prime. So instead of flag, if you want to make it clear, you can do is prime. Okay, so now we can tell that this is no longer prime number. So is prime equals false. Okay. So after that, immediately after this, you're breaking. So what happened to fall of len? It won't go for any other number. You found already a number 3 that is dividing 9. So it will break immediately and will come to this condition. Here what is it? I told if is prime is true, then only you have to print this. But what did we make prime as? We made prime as false. So false is equal to true? No. False can't be true. False is false, true is true. So this statement won't run. That's all. That's why you're not getting a prime anymore. The word prime is not coming anymore. Let's try another statement where it is a prime. Let's take example 11. Here it is a prime. Why? First we'll check with 2. 11 is not divisible by 2. So this won't run. 11 is not divisible by 3. This won't run. 11 is not divisible by 4. This won't run. So on so forth. It will go up till 10. Then 11 divisible by 10, not it won't run. And when I becomes 11, 11 is less than or equal to 11 is not true. So again, that won't run. Okay. So the whole time this prime variable never became false. So whatever was here will always be here only. You can just consider nothing happened here in this whole runtime. Nothing happened to this isprint. This isprint remained as it is. So again, then this is like this. Okay. If you want, you can do the opposite as well. You can do like here you can keep false. Here you can keep true. Any doubt? Let's go. Okay. You can take this way also. All you need to do is initially it has to be some number. Initially it has to be something. And in middle, if suppose if we see some other change in it, it has to change. You have to make sure that it alternates. That's the idea of this thing. Even this will work. We can just couple and check. Will work. Okay. This will work for any number. You can take 97. It'll work. Okay. So that's the part of this. Okay. So this is the use of for loop. For loop is used here so that you can go from all numbers. Break is used so that you don't have to go further. Because if you don't keep this break, there's a problem. It will hold on. Yeah. In case if we take something like 18, it'll print not a prime multiple times because first it'll print for 2 because 18 is divisible by 2, then 18 is divisible by 3, then 18 is divisible by 6, then 18 is divisible by 9. So for each of them it'll print. So for not, so if we find one, it's enough, right? So for that case, we are keeping a break. That's it. So that's the reason. And finally, an if condition, because even after doing all the things, if it does not change, if this state has not changed, it means it's prime. It's a prime number. That's it. Okay. So any doubts? Doubts. Okay. Yeah. Yeah. I plus plus increments by 1. Okay. Okay. So, no doubts, right? Yeah. Okay. If there's no notes, you can go on.
Thank you, Rohit, for walking us through the basics of conditional statements and loops. That was really helpful. And if you all have any doubts, do drop it in the chat box. Our team will reach out to you soon. And up next, I invite Sofian to continue with the insights of data structures and algorithms.
Thank you, Darshini. That was an insightful session from both Rohit and Nitin. Okay, guys, now it's the time I give you the gist of what DSA is. So, till now, you people have learned the basics of C++, input, output, loops. Okay, you have learned about loops, functions, etc. Okay, now we are going to see what DSA is. So, what DSA stands for is called data structures and algorithms. As the name suggests, DSA, as the name suggests, data structures and algorithms. What you can differentiate? Data structures, data being stored in a structured format, and algorithms are a set of so data structures and algorithms both together are called DSA, which is implemented in CPU computer programming. So here I'm going to give an insight into what data structures are. So data structures, what do you understand by the term data? As Rohit taught you what drives and data. When you say int x, I'd like you people to visualize what data structures are. Data structures mean the way of storing data in a structured format. Okay, storing data in a structured format is called data structures. And there are many type of data structures, and I'd like to show you some of them. Okay, so I'll give a gist of what DES is data structures. I think the screen is visible, and I want people to visualize what data structures actually are. So if I write the statement as int x equal to 10, as Rohit has explained you, int is the data type variable, and 10 is the value that is being stored into x. Int x equal to 10. So it's being stored in the computer memory. When you say int x, okay, just remove the 10 part one, okay? Okay, so just int x semicolon. Okay, I'm declaring a variable called x in the computer memory. So x is going to be allocated to it. Say this is the memory space being allocated to x. Okay, and if I write int, it has a specific space. You said 32 bits. Int stores 32
Sophie,
bits.
your screen
For us
is
to store int value,
Sophie, the screen is actually not visible.
not visible. Okay,
Yeah, I
let me
think the
just
Wi-Fi
share
is a
it.
problem.
Now, is it fine now?
Still blank, bro. Showing black screen.
Let's wait for a moment. It should start working. Guys, let's just check if the screen is now visible. Is it visible now?
Not yet.
Nah, your video and audio is choppy. It breaks in
Yeah.
the middle.
Can you give a check now?
Not yet.
Nah, are you
It's
presenting us live?
yeah. Yeah, no, it's fine.
Now,
Yeah, no, it's
now
fine.
it's working. Now it's working.
Right.
Yeah.
That's fine. Okay, guys. So I'll come back. I'll go for the int x. Now, when I say int x, a variable being is being allocated to the data x. Okay, x is of type int, and int is having a specific size on it. Okay, when I say int x, x is being allocated 32 bits. Int stores 32 bits of value, and this is the data that is being stored in the computer memory. Now when I say x to 10, the value 10 is being stored in the x data is storing 10. This is what happening in the memory. When you say int x equal to 10, this is the variable, and that's the data type, and that's the value. Structures, what they do, they store your data in an order. Okay, so there are different type of data structures. I'd like to get you people into the first data structure we're going to have in this session. I think people may seem very familiar to what this looks like. People might be familiar with what an array is. Yes, right? So what is an array? Array is a group of elements that are put together. Now I say int x equal to 10. Here there's a single value that is being held in the memory. That's being held in the memory. When I say vector, we're having a number of elements which are together. Now how do we visualize a vector? Okay. So when I say a vector, it is a group of elements together, as I said. 23, 32, 5, 11, 7 in this example. And have a specific index value. When I say vector first, we have first 23, 32. So what is happening? When I say vector, we can define for an array, if you take array as example, array is having a fixed size. When I say vector, vector doesn't have a fixed size. That's the only difference you can have between an array and a vector. Okay, again, if you compare it to int x equal to 10, you have single value. Vector is having multiple values. This is one of the data structure, a linear data structure. In the memory, we get 20, we have a blank space again. Okay, then there is first 23. When we insert 23 into the vector, first 23 is being stored in the memory. Then when I say 32, to the memory block of 23, 32 is being stored right. Get the idea, guys. 23 is first, and 32 is being stored next to it exactly. So vector is having two elements now. Both of them are being stored in the memory space right next to it. This 23 is 32. Okay. Then 5, 11, 7, and I can just say 7 is having the index 4. Every vector in the memory, they have an index, like index. 23 is starting from the position 0. Now, how are you going to access the elements in a vector? By using the
Sofian,
indices. Okay. Yes.
Sofian, actually, your network is very slow, bro, because the voice is very choppy and people are not getting it. Maybe you can turn off your camera, that's no problem. Yeah.
So does this work?
Better.
Better, or is still there a lag or something?
Mm, yeah, continue. We'll just see.
Fine.
Yeah,
Okay.
continue.
So we have 0, 1, 2, 3, 4. 5 values with index starting from 0 until 4. We have contiguous memory allocation done to 5 elements in a vector. So this is what the first data structure is. As you can see, vector is storing multiple elements together with contiguous memory allocation. So people visualized what a vector is. Do you have any doubt?
And now we couldn't follow what you were saying about vector. Can you just explain it again?
Okay.
Because
I'll give a brief explanation. Okay, when I say int x equal to 10, x is a single value stored. Okay, single value. When I say x int x, a single memory allocation is being done and a single value is being stored. On the other hand, vector, which is a data structure, is having multiple values. When I say a vector, it's going to have multiple elements. It can be 1, 2, 3, or any number of elements that are stored together. When I say vector, it is having a multiple elements stored together in a contiguous manner. And memory allocation is done side by side to every element. When I say 23, it is having a memory, and right next to 23, the next memory allocated is to 32. They're all together grouped at one place in the memory allocation. Okay, vector is basically elements together. Is that fine? I think that clears it out. Vector is basically elements together. Are vectors like arrays? Yes. Array is a group of elements. Vector is also a group of elements. Only difference between array and vector that you need to know is, which you're going to see in the code implementation parts. Array is having a fixed size. When you say array, okay, array is like you will have to declare array in such a manner like int ar of, I say, 5. What is happening? A fixed size of 5 is given. In the case of vector, you can either say vector may have fixed size or vector is dynamic. You say dynamic.
Second, I need to beat up
You know what?
again.
Come again? Okay. So when I say vector, it's going to have no, it's not going to have a fixed size.
Oh, that now, कुछ भी ऐसे serious दिवो. I know, he's a very big guy.
And I thought it was a doubt. Okay. Okay, guys. So now we're going to see the implementation of a vector. Okay. I think you people have visualized what a vector is. No doubt, right? No doubts. Yeah, I can go for the code part. Okay. Coming to the code. Now, how are we going to define a vector? I'm just going to write vector. Type of value is going to store and v. That's it. We have defined a vector here. Okay. Now, since vector is going to have multiple values, let's use a loop to put values. Let's say I want to push 5 elements. I'll say I less than 5. The loop is going to run for 5 times, guys. Okay, 5 times. I'll say int k. Okay. Let's say c in k from the user, and you're going to push it to the vector. Now, how are you going to push a value into the vector? Let's say v dot. Okay, guys, just v dot. Then you're going to say put underscore back of k. Is this clear, everyone? I'll just write a output saying from here output starts here so that we can differentiate between the input and output. And I'm going to say end line. And I'm going to copy this loop. Okay, and I'm going to just say C out V of I. Okay, now what is happening here? Int is going to start from the 0th element, and vector initially is being an empty vector. There are no elements or any, you can say, number. Yes. Okay. Initially, the vector is empty and it doesn't have any elements or values stored inside it. Okay. And int k is just a element, is just a variable I'm declaring for to take user input int k, because user is going to store the value in k first, and the value k is being pushed into vector later. Okay. The loop starts from I0, goes I5, means I is going to iterate from 0, 1, 2, 3, and 4. When I becomes 5, it's going to exit the loop because the condition is not going to satisfy here. Okay. And we're going to say output starts here. I'm going to start printing the output. Let's give a end line statement here so that we can see each element on a different out in a different thing. Okay. I think we can run this code. Okay. I'll say g++ rough.cpp. because my file name is rough here. Compile it. No errors. Dot -a.exe. Okay, Rohit Nitin must have used the over format. It basically can store this file with a specific name you want. Else, if you don't give a name specification, it's going to store a default a.exe file. Just been generated here. Okay, I'm going to run the file. Okay, it's asking us user input. I'll say 1, 2, 3, 4, and 5. Now, when I press enter, what do you think will be the output? Does anyone want to take a guess? What does push underscore back do, and do we need to use it every time while taking in values? Divyan shall come to your question. First, let's say, yeah. Anyone wants to take a guess for the output? Numbers will print. Yes. I'll press enter. Yeah, output starts here. Now, V of I. What does V of I specify? I starting from 0 and vector at 0th position. Index. We're indexing basically, guys. V of 0 is specifying the first element. V of 1 will specify the next element. See, I inputted 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5 is being printed out. So vector is storing 5 values inside it. Let's go to the visualization part. What is happening? Where is my window? Yeah. When I say 1, this were the values I inputted. Okay, 1, I said 3, then I said 4, then I said 5. And 1 got stored at the first index, which is 0. And for vector, indexing start from 0th position to 4. Okay, n minus 1. Getting it? So 0th plus 1 was there. These are the indexes, okay? Indexes, index positions. And these are the actual values that are being stored at that place. So 0 at 0th index, 1 was stored. Second index, 3 was stored. Third index, 4 was stored. And fourth index, 5 was stored. Let's take a better example. I'll say 11. I'll say 12. Let's take random 16. Let's say again here 3 is coming. Let's say 6 is coming. And we'll end it up with 7. 11, 12, 16, 6, 7. Let's implement the same with the vector again. Okay. Let's run the code. I said 11, 12, 16, 6, and 7. Same way at output as well. Now coming to Divyan's doubt, we can explain what number will print will this meeting. Okay. Explain code from start. Okay, Rishabh, I'll explain the code. The vector int v. This is the way we declare a vector. Okay, this is the syntax. Vector. Then in the triangle brackets, I'm just going to write the type of element is going to store the data type int. This vector is going to store integer type of values. V is the name of the vector we are giving. Okay, V will be the name of the vector here, and that's the declaration part. Int k is just a variable into which we are going to take user input. Int k will be taking user input into k here, and that user input is going to be pushed into V, means the vector. Okay, and loop is running for 5 times, considering we're going to input 5 values. Okay, guys, I think that and that explains your doubt. And just printing the values one by one with the help of a loop. As I said, indices. V of I specifying the index here. Okay. Now this is what a vector is. And again, Divyansha, do we need to use push underscore back all the time? Yeah. See, if I want to initialize a vector, say size 5. Okay, here I'm fixing the value 5. So here I can directly do this. V of I is equal, okay, I'm just going to say C in V of I. What is happening here? Since the size is fixed V of 5, V of 5 is going to store values from 0, 1, 2, 3, and 4 because size is fixed. Yes, guys, and one more thing, since I'm fixing the size, I'll say V dot size here. Okay, now what is V of size? V of size, okay, for STL library, structured template library, for any DSA structure you take, and if you put dot size, this is going to return the number of elements the vector or the data structure is holding. Okay, here v dot size is going to return 5 because we have declared the value as 5, means the size 5. Vector is going to store in 5 values. Is that clear? Output should be in reverse order, right? Nishantan, why should output be in reverse order? No, it's not required because the indexing from the start 0 now. Since we're indexing on the start value, it's going to start printing on the start. If you want it to be in the reverse order, yeah, we can do that. I'll just say I equal to 4, I greater than equal to 0, and I'm going to say I minus minus. Okay, let's for your out. Okay, I'm just going to input values and I'm going to print it in reverse order here. I'm going to compile it again. Let's say 1, 2, 3, 4, and 5. See, it's got reverse order because I want to start from index 4. I think that answers both your doubt. Okay. Yeah, just do it normally. So, since you got the reverse order, return equal to, I'll say v dot size, and it's going to be less than v dot size. V dot size less than it. Let's say I plus plus. Okay. Here, why we're not using push underscore back? We can use either push underscore back or we can use v of I because the value is fixed. When we're not fixing the value, we can store any number of values. So we're using push underscore back there because the index is not specified. Okay. Here, because we have specified the value, means the size of the vector, we can use directly v of I with indexing directly. Okay. Same way, we're just going to print it. Just to compile, I'm going to run it and say 1, 4, 7, 2, say 20. Same is going to be printed. So this is a vector. Yeah, Devyansh, again, Devyansh, that's the main difference between vector. Okay, that's I'm saying vector, you can either specify the size or you don't need to specify size. If I say vector, that's it. Okay, if I'm not going any, if I don't want to give a size, I can just say here, I can say, okay, for your indication, okay, you're asking why, I'll say int n. Okay, I'm going to say c in n. What I'm going to do, I'm going to prompt the user, see out, enter size of the vector. Okay, I'm going to say enter the number of elements you want to store. Enter the number of elements you want to store. Okay, I'm going to input n, and then I'm just going to use this loop here, guys. Okay. Okay, I'm going to say, okay, I'm going to say since the value n has been inputted from user, I'm going to put that many elements. Okay, I less than n, and I'm going to say v dot because it's going to be dynamic and say v dot push underscore back of k. I'm going to take input from user. Here, see. Here, n is being specified from the user. We don't know the size of vector in the start, okay? N is going to value which is going to be given by the user. User is inputting the value n. Because user is inputting the value n. And that is going to be the size of the array. We don't know the size here. And in the second iteration, while printing the output, we have given v dot size, which is going to indicate the size of the array. Okay? This is the difference between vector and array. Let's execute this code. Okay, I'm going to, okay, sorry. This is G++. A.exe. Enter the number of elements you want to store. Let's say 5 elements. Say 1, 2, 3, 4, and 5. See, 5 elements have been stored. The vector size is automatically incremented to 5 without being declared. V dot size is going to return as 5. Let's do one thing. I'll just print the value of v dot size as well for you people. So that you people know it's going to return the value. It's automatically been given, okay? Okay, I'm going to say 4. Okay, let's do one thing. I'm going to give a space here and I will say handle. Okay. Again, compiling. I'll run. Enter the number of elements you want to store. Let's say 4. I'm going to start inputting the elements now, guys. I'm going to start inputting 1, 2, 3, and 4. Done. First is the size. Okay, output starts here. V dot size, which is 4. Dynamically allocated. It's not fixed. We have nowhere fixed it. Okay. And then we are printing it. So this is what a vector is. I think that has cleared all your doubts. What's the difference between array and a vector? Why are we using a vector? Fine, guys. Okay. Now it's time we move to our next data structure. Okay. I'm going to share my window. See, data structures, it's better you visualize it because the more you visualize and you understand how data structure is storing values, the better you can perform operations on it. Now we have done a vector. Now let's go to the, I think the chat section has already, okay. I think people can see what I'm referring to here. The name is stack. What is a stack? As the name suggests, what you can try to understand from a stack, stacking things on top of each other. Stacking one on top of one each other, stacking, okay? So take an example of rice bags being stacked in a rice, if you don't go or a rice granary, or the rice bags stacked on top of each other. Rice bag top, bottom, one on top of it, one more, one more, one more. That is basically a stack. We're stacking elements on top of each other. Vector is having in a contiguous manner. Vector, you can access any element by indexing it. Because if you want to access 12, as I said in the loop, v of 0 is 11, v of 1 is 12, v of 2 is 16, v of 3 is 6. Okay? Coming to stack, we're stacking elements on top of each other. First 1 is coming, on top of 1, 2 is coming, on top of 2, 3, on top of 3, 4, and top of 4, 5. Okay? Visualize it. Stacking elements. How is the data structure being stored? Stack. One element, second, third, fourth. It's just going to go building on top of each other. They're stacking. You're getting the idea, guys? They're stacking. Okay, I think that was fine for the visualization. Shall we go to the implementation part? Okay, let's go for the implementation. Now we're going to implement what a stack is in code. Okay, I'm going to code it. Now, I'm going to change only one single word here. Stack. Then, will people have initialized a stack? That's it. Stack is just a stack. Type of value stack is storing. Let's change the name. Let's say S. Then stack S. People have made a stack now. Now, let's take inputs into stacks. Okay. Let's say I'm going to take, let's stack 4 elements. Okay. Int I equal to 0, less than 4, I plus plus. Now the difference comes. Now, how are you going to stack elements in a stack? We are going to use a function called push. Okay, s dot s dot put. Let's take input from user. The int k. Okay, I'm going to declare a value int k here. Okay, I'm going to push the value k into the stack. Now what is happening? Initially stack is empty stack. We're taking input from the user as well as we're pushing it on top of each other. So they're getting stacked. Okay. Now how are you going to access the elements? Let me share my screen again. Okay. So what we're doing from the user, we're taking element one by one and we're stacking on top of each other. Okay, they're getting stacked. So how are you going to access? Remember, guys. Now, if you're stacking rice bags on top of each other, how are you going to take a rice bag? Are you going to pull from the bottom? It's not possible. If you pull the rice bag from the bottom, the entire rice bag stacked on top of each other are going to collapse. Get the idea? How are you going to access? First, you're going to pull the topmost rice bag. They're going to pull the second most, and like that way, in sequential manner, going to start pulling rice bags from top to bottom. Okay, similar way. First, the lowermost stack element is going to stay there. We're going to access from the top. In stack, you can access an element from the top only. That's the you can say stacks implementation or how a stack performs. It's the functionality of a stack, to be honest. You can only access the topmost element. After use the topmost element, then you can go to the bottommost. Means you have removed the stack. People got the idea. After removing the topmost rice bag, we can then access the secondmost. Okay. the second last, I can say. Getting the idea? Once we have removed the topmost price bag, the topmost element from the stack, then only we can access the bottom one. Okay. Once we remove the topmost, then we go to the bottom element. So that has been popped. Now, how are we going to remove the topmost? Use a function called pop. Push is to push an element. We're going to push one on top of each other, stacking them. So then we're going to pop. Okay. Now let's first. Okay. Now, while printing a stack, we have to pop the element from the top and print it. So it's not going to be, we're not going to say directly cout s of I. Okay, I'm going to say int. Here we have 4 elements. We'll again use s dot size here. Okay. Int I equal to 0, I less than 4, I plus plus. Okay. Now, access the topmost element, we're going to say s dot top. Okay. We're going to say s dot top. S dot top is going to give us the topmost element. Okay. S dot top. I think it's screen is visible, right, guys? Yeah, S dot. Okay. First, you're printing the topmost element. Then you're going to remove it. As I said, once you're using element to access the S dot pop. I think people have understood what I'm trying to say here. We're going to input. Output starts here. To differentiate between the input and outputs. Okay, double quotes I'm missing, double quotes. Okay. Is that fine? Yeah, last and first dot, yes. LeFo, last and first dot, yeah. So going to access the element using s dot top is going to give us a topmost element. Okay, I'll show the implementation of size directly. Okay, s dot size. Okay. Again, size, we don't know the size originally. The number of elements you're pushing here is going to be the size of the stack, s dot size. Okay. So we're going to start, we'll execute this code for a moment. Let's just implement it. Okay, we're going to say x dot exe. Okay, let's start stacking elements. I say first element is 5. I'm going to say fourth, second last is 4, 3, 2. And output starts here. What's happening? You're printing 2, then 3, and you're popping s. Okay, s dot size is changing. Let's not do s dot size because, as I said, the size is decreasing. So the loop has not executed for the number of times. Let's say s dot 4 because you want the loop to execute 4 times because there are 4 elements. Okay, you want the loop to execute for 4 times because there are 4 elements. Let's recompile the loop. Recompile the program. It's a 5, 2, 4, and 3. Perfect. Output is starting. This is the topmost element. Visualize this, guys. I said 5 is going to be the bottommost element because it's being pushed first. Then 2 is being pushed on top of 5. 4 is being pushed on top of 2. And 3, the last element which is being inputted, is on the top. You understand, guys? It's being stacked top. When you're printing the output, let's visualize this. Okay. 5, 2, 4, 3. Okay. 3. First 5 was there, 2, 4, and 3. What was happening? We are going to access the topmost element first. So 3 is being used. Then after printing 3, we are popping it. Means it's removed from the stack. It no longer exists. Okay. Then you're going to use 4. Then 4 is being removed. Done. 2. 2 is being removed. Done. 5. And ultimately 5 is being removed. The stack is again empty because we consumed all the elements of the stack. Okay. Oh, I'm not saving it for here. Is that clear, guys? Was the visualization fine if people could understand it? Okay, I think you people understood stack. So let's go to the last data structure, okay, which is, yes, hash map. It's a very famous data structure, hash map. Okay, so hash map. Okay, a moment there. So people can see hash map is. Hash map is basically it's a structure again, but what's the difference? You're going to access an element in hash map with a key. Unlike in vector, vector has an index, contiguous value of memory, and each element is having an index. This is 0, 1, 2, 3, and 4. With that index, you're going to access the value in a vector. Whereas in stack, you're going to access only the topmost value. There is no concept of index in stack. Topmost value, consume it, remove it from the stack, and then come to the next value. Okay, that is the stack. Hash map, on the other hand, it has a value and a key. Here, the 10 is the key of the vector of the hash map. 10 is going to say Sachin. Okay, 10 is going to say Sachin. 10 is the key here, and Sachin is the value. The key 10 is holding the value Sachin with it. 10 refers to Sachin. 10 is the key, Sachin is the value. This key is referring to this value. Okay. Similarly, 7 is referring to Dhoni, 18 is referring to Virat, 45 is referring to Rohit. We will get it. Okay, can you show the example code again? Basically, dictionaries. Yeah. In Python, you're going to have something called dictionaries. Similar way, hash maps. Okay. Similar way. I show the example code again. Yeah, I'll show the code before let. Okay. Okay. I think people got a very good hold of what a hash map is. Okay. A key and a value. Key value pair, famously called as key value pair. Okay. Understood? You people visualize it fine. So let's go to the code part. Okay, let me clear my screen. Code. Yeah. Okay. Okay. Who was asking for example code? Okay, you people could see the code fine. Divyan, share. This is the code. Just popping the topmost element. After using the topmost element from s dot top, we are popping it. So the secondmost element is there in the stack. Okay. This was the example code for the stack. Now let's implement a hash map. So there's a slight difference. Since stack is stack, vector is vector, we're not going to directly write hash map, okay? So hash map has a name called unordered underscore map, okay? Unordered underscore map. I'm going to say int, comma, string. You people must have understood why I wrote int, comma, string. As I said, it's a key value pair. Key is referring to a value. So int is the data type of the keys, okay? Int is the data type of the keys here. And string is the data type of the values. Okay, values data type is string. Key int and value is of type string. Okay, guys, key is going to refer to a string value, integer key. Okay, let's change the name. Let's say MP because it's a hash map. Let's say map MP. Okay, change the value. Now, how are you going to take input? Let's start a loop again. For int I equal to 0, comma I less than. Let's say we're going to input 4 values again, I plus plus. Now we're going to take 2 inputs, key input and a value input. And I'm going to introduce you to something called as the iterator. Here iterator is I, but there is one more syntax, okay, which can be followed in both Java, C, C++, okay? We're going to come to that, okay? For now, I need a key and a value. So I need to declare 2 variables, guys, okay? Let's say int k, which is the key, and it's a string s value, okay? As the loop starts, we're going to input we're going to input the key first, which is k. We're going to input the value into s. I think that's fine with everyone. Yeah, it's fine. Okay. Now we're going to input into the map, hash map. How are we going to do it? MP of k. is equal to S. What is happening here? As I said, visualize the map, okay? I'll share my visualization part, okay, again once more. The more you visualize it, the easiest way to understand the code, okay? What am I doing? I'm going to input the key value. I'm going to input the key, sorry. I'm going to input the key and the value it's holding, okay? And when I say MP of I, okay, this is MP of I. Let's do one thing. Let's take a empty one, okay? And say control C, just take a control V, okay? Initially, this is the thing initially. What we're going to do, MP of I mean, I'm going to take a value here, K. Okay? This is going to say S, means a K string. I'm going to say it's a key, and here it's a value. This is what I'm doing with the help of MP of I. MP of K in my listing is equal to S. Okay. This key, MP of key is equal to S. This key inside this map is corresponding to this value. Okay. I think that's fine. That's the what I have written in the code. MP of key is equal to S. Okay, guys. Is that fine? Okay. Okay. So now we're going to input them. Okay. Okay, we're going to also print them. Okay. Now what, as I said, for everything, okay, let's say for int x of MP, what is happening? Okay, I'm coming to this part. X as a handle done. Okay. Okay, sorry. I'm going to introduce you to iterator, guys. Okay, auto ampersand P. Let's just not write this. Now, what is this? Auto is type of iterator. Here, there's no incrementing if people see. There is no condition checking, I less than or I plus plus. Auto is a type of incrementer in C++. Okay, in C++, auto is a type of incrementer. So what is ham% P? Ham% P is referring to the value in hash map. As I said, I'll share my screen, I'll share the visualization part. Okay. Yeah. This is P. P is going to refer hash map from top to bottom like this. Okay. First P is here. Then auto is incrementing P directly. P is going to come here. Is that fine? Okay. P is going to refer here. Then it's coming here. Here. Auto incrementing. Auto ampersand P. Auto incrementing. Ampersand P is referring to the location. First one, second, third, fourth. Okay. Here, a key value pair is going to refer to the first key value pair, second key value pair, third, fourth. It's going to automatically go. Okay. Auto incrementing. It's fine, guys. Automatically. Yeah. Okay. Now we're going to print it. Since P is pointing to the first location, I'm going to say P dot first. Let's print it C out. If anyone has any doubts, they can ask. I know it's like, yeah, P dot second. I'm going to say NL. What is happening? P dot first, P dot second. As I said, P is referring to the first value. Okay, first location. Yeah. And first. Let me reverse this arrow. Okay. Yeah. And P comes here. P dot first is the key. P dot second is the value. Okay, guys. P dot first. P is going to go from here, here. P is going to keep changing like this. And P dot first refers to the key. P dot first, P dot second. P dot first and P dot second. First is referring to the key. Second is referring to the value. Okay, guys. That is P dot first and P dot second. You have to visualize it. P dot first, P dot second. Okay. And P auto iterator P 10, 7, 18, 45. P is going like this in a sequential manner. It's going to just it's going to iterate automatically. Okay, let's come back to the code again. Okay, that is what happening. We're importing and we're going to automatically iterate p, starting from the first hash map value all the way to the end. Auto. Okay, and colon MP means has to refer to the locations in MP. Whatever has been stored in MP is going to start iterating from first till the last, one by one. Okay, I think that's fine with everyone. Okay, yeah, let's compile it. No errors. Okay, let's do one thing. I'll put a again cout output starts here to differentiate between output and input in the terminal. Output starts is it? Yeah, output starts here, and I'm going to say handle. Okay, yeah. I'm going to compile it again. Just for a second, and let's run it. Okay, let's say 1. And at 1, okay, not let's say 1. Well, let's take our classic visualization example that I given. Okay, I'm going to say 10. It says Sachin is in 10. I'm going to say 7. Let's say Dhoni is in 7. Let's say 18. I'm going to say Rohit. And guys, see, output is starting with Virat, Dhoni, Rohit, Sachin. Fine. And we have the key and we have the value. Is it clear with everyone? Auto be for stack 2. See, why I'm using auto here is stack is not, we're not using auto for stack because stack we're going to access the topmost element. Here, we're going to automatically iterate. Since there's no concept of index here, we are automatically using key to initialize to the memory location and go automatically. You're getting the idea. See, as I'm showing in the code, now is my, what am I showing? Is my screen, yeah. Auto is an auto iterator. It's going to automatically traverse the memory locations. Okay. Stack, we're going to access the topmost and going to pop it using. Got the idea? Okay, guys. Can you give another example for hash map? Another example for hash map. Okay, so, okay, I'll again tell you what an hash map is. I have to share my screen. Okay. Do you want me to give an example like a rice bag thing you're asking, or just what a hash map you want to explain again? Okay, guys, let me say I'm giving a registration number. Okay, it's a unique value. I'll say 25 BCE, let's say 1001. Okay. This is going to refer to your name. Okay. It's a unique value. It's not an index. Or like in the code. Okay, you want me to input an okay. Let's keep it 10 such in, okay. I want to save it, fine. Okay, coming to the code. Yeah. Okay, you want to give another example of hash? Do you want me to take a unique input again? Yes, okay. So let's take inputs. Okay, what can be taken as inputs? Okay, let's start executing the code. I'll say G++. Okay, we're going to compile and again. Okay. Okay, let's say I'm going to say a value 1. Okay, 1 I will say let it be. I don't know why I'm just taking random values at this point. Okay. Okay. And I'm going to say this. I'm going to say what is happening. One key. At 1, we're going to refer to the value Taha. Why? C in K, and we're going to take S value. K is the integer value. 1 is going to be going stored in K. K is having value 1, which is the key. S is the value of the string, which is daha. Daha has been stored in S. So what are we going to say? MP of K equal to S. MP of this key should refer to value S, which has been inputted by the user. MP of 1 is equal to daha. So at the value 1, key value 1 is daha. Similarly, after inputting first value, loop is going to say I equal to 1, going to input again. Okay. So we're going to input 2. At 2, we're inputting Simon. So at the key value 2, Simon is being inputted. We're getting the value as visualized in the hash map. A key is having a value to it. So 1 is having Daha, 2 is having Simon, 3 is having Deva, and 4 is having Kailasha. You people get it? Please explain auto again. Okay, I'll explain auto again. Okay. Let's just input. Yeah, same. See, Daha, Simon, Deva, Kailasha. Okay. We're outputting the key value, key value, key value. Okay, you people want to explain auto. Okay, guys. I'll give it a traditional way of okay, traditional loop, which is the traditional loop we're writing till now. Int I equal to 0, I less than 9, I plus plus. This is the traditional loop. Okay. N has not been defined, let's say 5. Okay. What is auto is? Auto is an iterator. It is called an iterator. If you say what is the iterator variable here? Iterator variable is I because I is iterating for 5 times, which is making the loop run for 5 times until this condition is met here. That's clear with everyone. And it's automatically incrementing. If I remove this I++, it's going to become a for loop. It's going to become an infinite loop. It's not incrementing, and 0 is going to remain less than 5 all the time. Okay. That's for loop. What is an iterator is auto. Okay. Auto means it's going to automatically increment. Or you can say ham % p. As I said, p is not a variable here. It's memory location. It's going to refer to MP's memory location, MP, okay? The first memory location of MP, P, ampersand P, is going to refer. Okay, I'll show you the arrow, okay? See, this is the arrow now. This is ampersand P here. Okay, this arrow here. Okay, yeah, this is ampersand P. This is going to refer. Since there is no fixed value, P is going to keep iterating automatically, auto iteration until MP is ending. Until MP is ending, it's going to automatically increment to all its values. Okay. 10, 7, 18, 45. This is an example. It's going to automatically keep incrementing. That is auto. We call it as an auto is an iterator. It's auto. Automatically, it just keeps iterating. There's no condition. It's going to iterate. Since I get a call in MP. Call in MP specifies until all the values of MP have been iterated. Keep iterating until it goes to the last. When it goes to the last, it's going to just stop the loop. That is auto. Okay. For what is ham % pin y p dot plus p dot second. So why does that work? Okay. Okay, I'll again say again. As I said, p is going to iterate like this in a top-down manner. 10, 7, 18, 45. Okay. That is p. P is pointing to the memory location of a map. Okay. It's going to keep iterating until the map ends one by one automatically. Until all the values of the map are ending, it's going to keep going until it's ending. Okay. That is ampersand p. Okay. Ampersand p address of values is correct or not? Address of value. Okay, see. If you go to the pointers concept, P, if I say ham % P, is going to go to the address. Okay. When I say asterisk P, the value at that address is going to be asterisk P. Ham %, it represents the address memory location. That's what I'm trying to say. Ham % P is going to the memory location. Okay. It's going to go to memory location, first memory location, second, third, fourth. It's going to go until all the memory locations for the map have been completed. Okay. I think that clears what a ham % P is. Memory location, yeah, it's memory location, yeah. Now, what is P dot first? As I said, P is going to keep iterating from here, here, here. And P is having key and a value. P dot first is referring to the key, the first thing. P dot second is referring to the value that key is holding. We get the idea. P is like this. P is going like this. 1, 2, 3, 4. For each P, there's going to be P dot first, which is the key, and P dot second, which is the value. In a hash map, we have a key and a value. For each memory location, there is a key and there is a value. P dot first is referring to the key, P dot second is referring to the value. And that's what we're trying to do. For each iteration, starting with the first element, P dot first is given to the key and P dot second is the value. Then we're printing it. Then auto incrementing to the second memory location. Second memory location first, second memory location second. First is a key, second is a value associated with it. You're getting the idea? Okay, got it. Thank you. And just say Anna is fine. Anna, yeah. Okay, same way. Ham first and P, auto. Okay, for people, if you people are feeling auto is a bit, okay, I'll give a similar thing. Since I wanted to do it manually, it's automatically I've done this. Now, I think I know what the index is. I want to access it with the index value. I mean, it's a key value. Okay, I'm going to see out MP off. Now I will say, okay, I'll give an input such that it is 1 to 5. Okay, 1 to 5 inputs are there. I'll say MP of, I want to print MP of 1. Okay, what is it going to do? Whatever is at the first key, okay, that's going to be printed here. Okay, guys, just look at it. Okay, I'm going to compile it. I'm going to run it. Now I'll say 2 is Simon, 3 is Deva, 1. Okay, key value 1. Key value 1 is Daha, 4 is Kalisha. Now people want to guess the output. Okay, key value. You will want to guess the output. Actually, people from anywhere in the hash map or is it like stacks and entering? Anywhere, yeah. Hash map is not stacking. It's going to, you're going to access a value with the help of a key. Every key is going to giving a value. Okay. Auto iterated directly starts. Okay. I think that's fair anyway, yeah. Okay, who wants to guess the output for this thing? I'm going to print the value with key 1. And I given the input 2 is Simon, 3 is Deva, 1 is Daha, 4 is Kalisha. So what is going to be the value at key 1? Key 1, what's going to be value? Anyone can take a guess. Okay, Daha. Who wants to give another guess? Same, or you want to say there can be another value? Daha. Okay, people are getting smart, of course. People are very smart. Where's input? Output is Daha. Why? I'm only printing the key value 1. Okay. Now, if I'll say, okay, guys, given, let's assume that you're going not giving a random key and you're going to just give a value key, let's say 1. Okay. And key is going all the way till less than or equal to 4. Okay. Let's say key is 4. I'm just going to say C out MP of 5. What is happening here? Okay. Here there's no auto iterate. Auto is going to go from locations here. I'm directly accessing with the help of a key. MP of I, MP of 1, MP of 2, MP of 3, and MP of 4 is the last. Okay. And we're going to take input 1 less than or equal to 4. Okay. Now here we don't have to take the key value because we're specifying the key directly. MP of I is equal to S. We're going to say only C in S. What is happening here? Key is 1, so value is the. Why does auto print in reverse, Anna? See, auto is not printing in reverse. For a hash map, there's no specified, there's no order. Each time you take inputs, it's going to print in a random way, or is going to be reverse. Sometimes it's going to go up and down because hash map, the accessing is being done with the help of key. There is no specified manner. Okay, if you want to say you want to have specified manner in a sorted way, there's something called a map. Why does auto print in reverse? It is not always, it's random. Yeah, it's random. Most fish memory action prints it. Yeah, because hash map is not ordered, it's going to take key value. It's based on key value. It's mapping a key to specified value. There's no order. Okay. I think that should, it works. Okay. Yeah, it's fine. Okay. Let's go for printing. Okay. Now I'm going to only input the values here because the key specified key is going from 1 to 4, as you see here. 1, 2, 3, 4. Let's say 1 is Daha, then I said Deva, I said Simon, I said Kalisha. Now it's going to print people who wasn't truly would have. Okay, guys, so done. Output starts here. Okay, give an endl. Okay, I'll give endl. Okay, I compile it. Running. Now I'll say Sachin, I'll say Dhoni, I'll say Virat, I will say Rohit. Output starts here. Sachin is at the key value 1. You see, key 1. Dhoni, Virat, Rohit. They're getting the idea. You're mapping key to the value. What was auto iterator doing? Auto iterator was going to the memory location. First, second. What is the estimated time? Okay. So, okay. There's one more session by next time. Is the memory allocation contiguous? No, it's not contiguous. Memory allocation not contiguous. Only vector has contiguous. Okay. Vector is side by side similar to array. Here it's going to key value mapping. Okay, guys. Hash map mapping. Just remember hash map mapping. Key mapping to value. Key mapping to value. Okay. The hash map should be between. Yeah, that's it. So are you people clear with vector, stack, hash map? You people visualized it, how they work, and even the code implementation part is clear, right? Let's see all the data sources for final time together, visualizing them. Quick recap. Normal way of storing a value. Data structure, storing data in a structured format. First is a vector, contiguous, one after the other. Okay, vector. Then we're going to stack top of each other. We're stacking them. We're pushing them on top of each other. Push function. Topmost element is accessed by using top. After accessing it, we're going to pop it using pop. Then we're going to the second most element. After this gets deleted. Similar way, this one deleted, popping it, go down. Okay, guys, that is stack. And this is hash map. A key is referring to a value. Okay. So these are the data structures I wanted to introduce you to today's session, the basics of DSA. Hope you people understood a gist of what DSA is. Basically, data structures storing a structured format. Thank you guys. This was data structures from my part.
That was spot on. Thank you, Sofyan, for introducing us to the concepts of vector, stack, and hash maps, and also for giving us a clear gist of DSA. Guys, do we have any other queries before we wrap up the session? Please do drop them in the chat box. Thank you for actively participating in today's session and was really happy to see the chat so active. And to all those who stayed till now, I truly appreciate your time and energy. A special thanks to our leads, Rohit, Nitin, and Sofyan for guiding us so well. We hope you find this boot camp both interesting and as well as informative. To stay updated and to participate in more such exciting events, make sure to follow Coach Chef on our social media platforms. Until next time, this is Coach Chef signing off.
1 second, guys. I really want to take a moment to appreciate you all. Hi, everyone. I'm Anika here from Coach Chef. You guys have been really crazy and interactive. Like it's 11:37 in the night, and still you guys are here learning and asking doubts. Really, we didn't expect this crowd to be this much interactive. Thank you all for being a part of this, and for those who have registered for Decode DSA 2.0, we'll see you all there to show the same support and enthusiasm in Decode DSA as well.
Guys, regarding certificate thing, you'll get it on events of. Recording guys will share in the group.